Okay, ladies and gentlemen, so here we are. We're in Chapter 2, and we have done a bunch of the lessons previously, and we are up to factoring simple trinomials. So before we get into actually factoring, let's review our expanding ideas. So I have two binomials here, and they're being multiplied by each other. And what's going to happen is we're going to expand those. The word expand means to distribute. So x squared plus 2x plus 5x, that's a 5, believe it or not, and plus 10. What we do next, that's expanding. So next we simplify, so we collect like terms, and it's going to be x squared plus 7x plus 10. Pretty simple. It's what you were doing last day. Should be straightforward. Let's do the same thing over here. So we're going to expand. The expanding part is x squared minus 3x plus 6x minus 18. And the simplify part is the collecting of like terms, and that's going to be x squared plus 3x minus 18. A couple of things to understand here, that when we go this way, when we start with two binomials and we move forward to get the trinomial, that is called expanding and simplifying. But when we go the opposite way, which is what we're going to be talking about today, that is called factoring. Now let's talk about why it's called factoring. I have two things that multiply to give a trinomial. The actual statement looks something like this if I wanted to write it out linearly, in a line. So this is very similar to me saying something like this, 3 times 4 equals 12. So these are factors of 12. Each one is a factor. So here's my trinomial. Each one of these is a factor of x squared plus 3x minus 18. Now, something else we should notice. Let's take a really close look at another example. Grab a piece of paper here. I'm making this example up. Let's look at x squared plus 7x plus 12. I made it up. Now, that is going to be able to be factored into x plus 3, x plus 4. Now, I know that. Let's look at what happens when we expand this. That's going to equal x squared plus 4x plus 3x plus 3 times 4. So instead of doing 12, I'm actually going to write out the 3 times 4 because that's what you're doing. Then let's pay particular attention to some interesting similarities here. This 3 times 4 is the 12. And it came from 3 times 4. So these two numbers get multiplied to give me that number. And these two numbers get added to give me this number. We're going to come back to this example a little later on, but let's first practice some skills that we need to be able to do this, and then we'll see how it all comes together. So, we're just going to talk about coming up with some numbers. That's going to help us factor. This is only part of factoring. For each of the following, determine two numbers that multiply to the top number and add to the bottom number. So we want a positive 6, and we want them, so it needs to multiply to 6, and it needs to add to 5. Now you may know that off the top of your head. Two numbers that multiply to 6 and add to 5 would be 2 and 3. So you would write them, 2 and 3, and we would check. 2 times 3 is 6. 2 plus 3 is 5. It doesn't matter if you put the 3 first and the 2 second, because order of multiplication does not matter. If I asked you what 2 times 3 was, you would correctly tell me 6. If I asked you what 3 times 2 was, you again would correctly tell me 6. So again, we want two numbers that multiply to give 40 and add to give 13. Now, some of you out there can think about that, and you know your times tables really well, and you know that two numbers that multiply to give 40 and add to give 13 are going to be 5 and 8. 5 times 8 is 40. 5 plus 8 is 13. Others of us, me included, would have a hard time with that. That would actually be difficult for me. So what I would do, and what I suggest you all be able to do, is something called a factor tree. So we're going to start with this number of 40, and we're going to come up with all the factors. Not just the right ones, but all of them. So we'll go 1. 40 divided by 1 is 40. 40 divided by 2 is 20. 40 divided by 3 does not go evenly, so we don't worry about it. 4 is 10. 5 is 8. If I don't know that, I use my calculator. 40 divided by 5 is 8. 6 is the next one I do. 40 divided by 6 doesn't go evenly. 7 is the next one I do. 40 divided by 7 does not go evenly. 8 is the next one I do. See, I'm going up in order here. 40 divided by 8 is 5. Notice these have been duplicated. As soon as that happens, you can stop. Now, since these are duplicated, we can disregard that one. Since these don't factor with two full whole numbers, we can disregard these. What that leaves us with is 1, 2, 3, 4 pairs of factors. All of these factor or multiply. All of these multiply to give 40. 1 and 40, 2 and 20, 4 and 10, and 5 and 8. Now your job is to find out which one of these 4 pairs adds to give 13. Ain't 1 and 40, ain't 2 and 20, ain't 4 and 10, 5 and 8 works. This will get faster for you. This is what you need to do. 12 and 7. Let me show you how quick I can do this. 12. 1 and 12. 2 and 6. 3 and 4. 4 and 3. These are the same. I can stop. So which of these 3 pairs adds to give 7? It ain't 1 and 12. It ain't 2 and 6. It's 4 and 3. They multiply to give 12 because they're one of these pairs. They add to give 7. 8. Well, they have to multiply to give 8. They have to add to give 9. 1 and 8. 2 and 4. 3 doesn't go evenly. 4 and 2. Well, that was kind of silly. 1 and 8's the only thing that's going to work. And 70 and 17. As you work on this, some of you will be able to do it quickly. 10 and 7. 10 times 7 is 70. 10 plus 7 is 17. It works out well. All right, that was where the top is positive and the sum is positive. When we look at the top, you'll notice that it's positive. That means if the top is positive, then the two numbers must either be positive or both negative. That's the only way they're going to multiply to give a positive. And if they're going to add to give a positive, well, then they can't be negative. So they're definitely positive. Compare that to this. The top is negative. The only way I'm going to get two things to multiply to a negative is if one is positive and one's negative. There's no way around it. One's got to be positive, one's got to be negative. They're going to sum to positives or negatives, depending on the question, but one's got to be positive, one's got to be negative. So I'm looking for two numbers that multiply to give 18 and add to give 3. Well, 6 and 3 make sense to me. They're going to multiply to 18. And they can add to give 3 if the 3 is negative. So let's think about that. Negative 3 times 6 is negative 18. Negative 3 plus 6 is 3. So that works. Negative 28 and 3. That's a little bit harder. I think I'd go to my factor tree just because I don't want to make a mistake. 1 and 28. 2 and 14. 3, I'm not sure. 28 divided by 3. Nope, doesn't go evenly. 4 and 7. 5 doesn't go evenly. 6 doesn't go evenly. 7 and 4. So these have reproduce. So I've got 4 and 7 and 7 and 4, so they're duplicates, so I can stop. That's how I know to stop. So it's either this pair, this pair, or this pair. Which one of those pairs will go together to give me negative 3? Well, it ain't going to be 1 and 28, ain't going to be 2 and 14. It must be 4 and 7, but one's got to be positive, one's got to be negative. To be able to get a negative 3, the 7's got to be negative. Okay, so we just continue. We continue and continue. Two numbers that multiply to give 4, add to give 0. Well, it's got to be negative 4. So negative 2 and 2 is negative 4. 2 plus negative 2 is 0. 56. I think that's 8 and 9. If you didn't know that, you'd use a factor tree. Let me show you one more time, the factor tree. Or it's not 59, it's 56. So 56. 1 and 56. 2 and 28. 3 I don't think goes evenly. 56 divided by 3. No. 56 divided by 4? Yay! 56 divided by 5 doesn't go evenly. 56 divided by 6. Yeah, no. 56 divided by 7. 8. Ooh, see, I would have made a mistake. 50, and then 56 divided by 8 is 7. These double over, so I stop. Get rid of that one, get rid of that one. The only ones that could work is this one, this one, this one, and this one. Which ones could go together to give 1? This one. And it needs to be positive 1. So I guess the 8 is positive, and the 7 is negative. I would have made a mistake on that had I not used my factor tree. Use your factor tree. 15 and 2, well, that's going to be 5 and 3. That gives me 15. And to get the negative 2, the 5 better be negative. Negative 5 times 3 is negative 15, negative 2. All right. Negative sum. So the top is going to be positive, which means it's got to be a positive times a positive or a negative times a negative. And the bottom's going to always be negative. So if the bottom's negative, and if the top either has to both be positive or both be negative, then they're both going to be negative. But let's take a look. 10. Two numbers that multiply by 10 but give me 11. 1 and 10 work, but they both have to be negative. Negative 1 times negative 10 is 10. Negative 1 plus negative 10 is negative 11. 20. 4 and 5 will give me the 9. But I want negative 9 and I want positive 20. So they both have to be negative. 22. I think that's going to be 11 and 2. That multiplies to give 22, but they have to add to give negative 13. So they both better be negative. 2 negatives still give me the positive. 12. I think that's 4 and 7. 4 and 3. But they both have to be negative. And finally, 30. I think that's going to be 6 and 5. But they both have to be negative. So if we can do this, we can now factor. I'm going to stop the video here. We'll flip over the page and do the next question.